So for number 9 from the Canvas assignment, it says that a roller coaster starts from rest at a height of 31 meters. Okay. And what's the speed at 16 meters off of the ground? So here's what we have here. I'm going to have a roller coaster like that, right? Perfectly drawn roller coaster, I should say. There's me in here with my hands in the air, waving them around like I just don't care. And from here to the ground, it is 31 meters. And then they want us to figure out what's the kinetic energy at 16 meters. So let me move my face out of the way. So the first thing we need to know is that the energy is conserved. So the initial energy, and I'm going to use the subset I for initial, has got to be equal to the final energy. Does that make sense? So then we have a combination of kinetic energy initial plus potential energy initial should be equal to the kinetic energy, whatever that is, final, plus the potential energy, final, because it's conserved. Well, how fast is this thing moving when it's at the top of the hill? The initial velocity of the roller coaster at this particular point in time is 0 meters per second. So my kinetic energy, and let's write in the formulas too. This will be 1/2 times the mass times the initial velocity squared plus the mass times the acceleration due to gravity times the height. And this is the initial height, right? And then over here I have 1/2 times the mass of another velocity that we'll calculate in a second, because that's what it's asking, plus the mass times the acceleration due to gravity plus the final height. All right? Well, I'm going to divide everything by the mass. Okay? So I'm going to take that whole thing and I'm just going to divide each term by the mass. Now what that does is that gives me 1/2 times V naught plus GH sub I is equal to 1/2, because the mass of the cart is the same, times the final velocity plus the acceleration due to gravity times the final height. Okay, so now I just plug some numbers in and go from there. So I'm going to have 1/2 times the initial velocity, which is 0 squared, plus 9.8 times times the initial height, which is 31 meters, which is equal to 1/2 times the velocity squared. Oops, we don't know what the final velocity is. And then plus 9.8 meters per second times the final height, which is 16. Okay? This goes to 0, right? Okay. So now, what's 9.8 times 31? Well, let's see. 9.8 times 31. So the initial potential energy at the beginning of this thing is 303.8 joules. And that is equal to 1/2 times the velocity squared plus 9.8 times 16. So we got to plug that in our calculator. Why do I have two of those? I clear that out, and I'm going to say 9.8 times 16. That's my final height. So that's 156.8. I'm going to subtract 156.8 from both sides. And this is joules, this is joules, this is joules. So if I say 303.8 minus 156.8, is that right? 147? Let me just double check my math real quick here. So I'm gonna say 9.8 times in parentheses 31 minus 16. Yep. Is equal to 1/2 times the final velocity squared. I'm going to multiply this by 2, and I'm going to multiply this by 2. Again, pull out my handy-dandy calculator, multiply this by 2. I get 294 joules is equal to, whoops, why did I do so many of those? The velocity squared. So now what do? Take the square root of both sides. And so if I take the square root of 294, I get 17.1. So that's the correct answer.